Sometimes it is desirable to carry out a marginal analysis related to average cost, which is cost per unit, average revenue, and average profit. So, if X is the number of units of a product produced in some time interval, C bar of X is denoted to average cost. Or cost per unit. And derivative of the C bar of X, okay, so first you should calculate C bar and you differentiate. So in other words, derivative of 2 C bar X with respect to X denotes marginal average cost. And analogously, you can define the average revenue R bar, which is R of X over X, average revenue, and derivative of the R bar, D over dx R of X. This is marginal average cost, and for the profit, P bar is the Px over X is the average profit, and derivative of the P bar of X is the marginal average profit. On the following example, I will explain the interpretation of these results. So, a small machine shop manufactures drill bits used in the petroleum industry. The manager estimates that the total daily cost in dollars of producing X bits is this cost function, okay? Cost function. So find the C bar. That is not difficult. So part A, C bar X is Cx over X. So which is 1000 plus 25x minus 0.1x square over X. That is 1000 over X plus 25 minus 0.1x. And this is average cost. So marginal average cost is derivative of the C bar. So you should differentiate this function to calculate the average marginal cost. So derivative of derivative of 1000 over X is minus 1000 over X square, because derivative of the 1 over X is minus 1 over X square. Derivative of 25 is 0, and derivative of minus 0.1x is 0.1. So this is the marginal average cost. Okay, let's interpret. Marginal average cost. This is our average cost. Let's look to part B. In the part B, find the C bar. Just as a calculation question. We calculate the C bar at the point 10, and you will see these values are different, and C bar, derivative of the C bar at the point 10. And in the last part, I will interpret that result. So C of 10 is from this equation. Easily you can evaluate 1000 over 10 plus 25 minus 0.1 times n. So this is 100 plus 25 minus 1. So that is 124. Let's calculate derivative of the C bar at the point 10 when the production level is 10. So minus 1000 over 10 square minus 0.1. This is 10 minus 10.1. So what does it mean? So at production level of 10 units per day, the average cost of producing a bit is $124. This cost decreasing, because it is negative, decreasing at the rate of the $10.10. Okay, we can write that in that form, $10.10 per unit. So let's interpret C. Use the result in part B to estimate the average cost per bit. So this is the mathematical meaning of the marginal average cost. So use the result in part B to estimate the average cost per bit at producing level of 11 bit per day. Okay. So for the next one, if production is increased by 1 unit, 1 bit, then the average cost per bit will decrease. Actually, I would like to emphasize why this decrease. This is decreased because of the minus sign, okay? So will decrease by approximately $10.10, okay? So the average, I could not write the average, sorry. The average cost per bit at a production level of 11 bits per day is approximately, okay, $124 minus 10.10, okay? So that is $124 minus 10.10, which equals $130.90, okay? So this is our estimation.
Birbirinin yerine geçiyor olmuyor.